Hello friends, this is Dr. Siva Nagaraju, Associate Professor from IARE. Today we are going to discuss VSB, modulation, frequency domain and time domain description. So what is VSB? The full form of VSB is Vestigial Sideband. So why this VSB is coming? Before VSB, we discussed about the SSB, single sideband modulation. So the problems what is coming from this SSB that is overcome in this vestigial sideband. So what are the drawbacks or the difficulties which is coming from this SSB is in this slide. So mainly two difficulties of implementing SSB modulation. The first one is designing and implementing the sharp low pass filter is not easy for circuit designer. That means sharp edges. You know that the filter characteristics of a low pass filter is just like this. So this sharp edge, what is difficult to design for the circuit designer. And another problem is this message signal which does not contain a significant energy in the DC area is often modulated by the SSB, such as the speech signal. So these two difficulties are raised by this VSB, vestigial sideband. Okay. So this is our vestigial sideband. And in this picture, you can see that VSB. So VSB is nothing but one sideband is fully, and another one is a part of that second band. Already you know that we're having two sidebands. One is upper sideband and another is the lower sideband. Both sidebands having the same information carrying. So that's why we are going to eliminate one band and sending, that is called as SSB. So in this SSB, the problem is the filter design. So we are getting some relaxation by using this VSB. So we are sending a trace or some vestigial part of the second band we are sending. So this name is called as a vestigial sideband. So the bandwidth required for VSB, vestigial sideband transmission, is somewhat higher than that of SSB. Why? Because in SSB we are sending only one band, but in VSB some part of that another band is sending, another sideband is sending. So that's why some more bandwidth is utilized by this VSB. So this is a frequency domain description of this VSB. So the first picture having a spectrum of message signal is showing. So the message is oscillating from -FM to FM. And the lower picture we are giving this spectrum of VSB. So here we are sending a full sideband 1 completely, and another one is a part of sideband, that is a vestige part. So that is shown in this spectrum. So here FC is the carrier frequency which is located at the center. Right hand side of this FC you can call it as USB. So the full USB is sending, and the left part of FC we can call as LSB. So some part of LSB is also transmitted. So this is spectrum of VSB. So this is frequency domain description of VSB. Okay. Now the transmission bandwidth is given by FM plus FE. Why? When compared with this standard AM, this bandwidth is 2 FM. That means we're sending 2 sidebands. So bandwidth for standard AM is double of FM. But here in vestigial sideband, we are sending FM plus FE. FE is the width of the vestigial sideband and FM is the message bandwidth. Again, this VSB is compared with SSB. SSB having only one sideband, so that is FM. Okay, and 2 guard bands are laid on both sides of this VSB. Why this guard band? That is to avoid the interference of signals. Now, what are the advantages and disadvantages of this VSB? So first, I will discuss about advantages. So it is highly efficient, reduction bandwidth, and filter design is easy, and high accuracy is not needed, and the transmission of low frequency components is possible without difficulties. So these are all the advantages of this VSB. And what are the disadvantages of VSB? One is the bandwidth. So it requires more bandwidth than that of SSB. Why? Here we are sending one full sideband and vestige part, some part of other band, and this demodulation is complex. So these are the disadvantages of VSB. And applications where we use this VSB. VSB modulation has become standard of transmission of TV signals. So generally it is used for video signals. So because the video signals need a larger transmission bandwidth, is transmitted using DSB FC or DSB SC techniques. So DSB FC, that is a double sideband full carrier, is nothing but a standard AM. And another is a DSB SC, there is a double sideband suppressor carrier. Okay. So these are the applications where I use this VSB modulation. Now we are using this time domain description of this VSB. So in the time domain description, this DSB is the modulated wave. And first, how this VSB is generated. Here, we are sending a DSB SC wave through a filter. So that filter will shape that DSB as a signal and produces our VSB signal. So this filter, what you discuss, this filter is our side shaping filter. So here you can see that is FC carrier frequency and FC plus FV, there is some part of vestige, and FC plus FM. So already you can see in this picture. Now the DSB is the modulated wave is which is represented as AC M of t cos 2 pi FCT. Let the sideband filter can be replaced by an equivalent low pass filter with the transfer function of H tilde U of F. So here U indicates we're using this upper sideband. Using upper sideband. Now this S tilde of DSB SC of T, which is equal to AC M of T. Our aim is sending full sideband 1 and another half, another sideband is some portion or trace or vestige of another band. Okay, so that's why we are sending this double sideband suppressor carrier signal to a filter. Now let the low pass signal S tilde of T denote the complex envelope of USB. Envelope of USB. Well, S of T. So we're taking this real part S of T, which is equal to the real part of S tilde of T exponential J2 pi FCT. So here we are going to determine this complex envelope of USB. Complex envelope of USB. So we may express this transfer function of this filter as the difference of two components. That is H tilde of F, which is equal to that upper transfer function minus this HV of F. So these are the transfer functions of the filters. Okay. So now this H tilde of U of F can be represented as a signum function, and this equation, which is going to substitute in equation 4, we can get this H tilde of F function, transfer function. So we are going to find this transfer functions HQ of F also, which is equal to 1 by J signal function of F minus 2 H tilde V of F. So after solving these transfer function equations, we are getting this final USB signal. So different operations are done by this side shaping filter, and finally you get the output of this one. So this one. So here we are considering only the real part. So S of T, which is equal to AC by 2 of M of T cos 2 pi FCT minus MQ of T sin 2 pi FCT. So one is a full sideband. So the full sideband here you consider as upper sideband, and the vestige of LSB is another one. So this is time domain description of VSB. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.